Joining us today on Superheroes of Science, we're so excited to welcome Lindsey Britt. Lindsey's a product formulator for Procter Gamble. Is
great.
Product formulator, right? I know I just asked you. Okay.
There you go. That's perfect. Awesome. So I'll be presenting today about cosmetic chemistry and how I've been a deodorant formulator for the past 3 or 4 years. So first I'll tell you a little bit more about me. So I went to Purdue University. I graduated with my Bachelor's of Science from there. And while I was at Purdue, I was actually an intern in between my years of classes. So I would go between going to school at Purdue, going to my summers to Procter Gamble, and back and forth. So P&G is, they sell a lot of different kinds of products. I'll kind of expand on that a little bit more, but what I specifically do for them is that I formulate beauty products. And more specifically, it's been a lot of natural products. So that's become a more important space for people in recent years. People are more critical of what's in their products and they want to know all the stuff. They don't necessarily just believe that things are safe just because they're for sale, which is understandable. So I've been with P&G for 4 years. So the first 3 years, I was kind of more focused on deodorant specifically. So that was like natural and aluminum-free deodorant. They kind of go hand in hand in that space. If it's natural, it's also aluminum-free is what I mean by that. And then the last year or so, I've moved to a new role where I'm kind of broadening what I work on. So now I'm working on a variety of beauty products that are still natural, but not necessarily just deodorants. So I've kind of included some different pictures here of, some of the different things I've worked on. I've made products for Secret and Old Spice, which are maybe 2 of the big, most recognizable brands that you'd think of coming from P&G. That includes deodorants for both of them. And then I also did an anti-chafe stick for Old Spice that you can find everywhere else still. And then, so I've also been working on essential oil fragrance roller balls, which is the each and every product here in the middle. And then dissolvable makeup remover wipes, which the way they work is you rub on your eyes and they take off your makeup and then you stick it under running water and they dissolve away instantaneously. It's really cool. And then another one I've been doing recently is a facial oil, which is like an alternative to a jar moisturizer. It's kind of becoming a little more popular recently. So kind of in this space of doing big innovative things, I'd like to say, without tooting my own horn, but that are maybe not the current most popular products. So we expect that these will become more popular is kind of the idea of the group that I work in. So there's this whole initiative at P&G called Responsible Beauty. You can think of this as being an initiative where we're trying to get more sustainability projects into our portfolio. In the past, P&G has, excelled in creating products to serve the world's consumers, but there's a need for us to, get with the current state of things in the world and start trying to incorporate more sustainable practices into what we do on our daily basis. So from this work, I've actually acquired 2 patents. So those are the plaque here on the right with my little gold icons there. So these are important for us because when you're formulating cosmetic products, you can formulate so many different ways. There are a lot of possibilities. Patents in this space are pretty more common, I guess you'd say, than other STEM fields. So it's been really cool that I've been able to get to already at my age, which is exciting.
Congratulations, that's awesome.
Thank you, yeah. So I think I said this, I have a BS in chemistry from Purdue. I also minored in statistics, biological sciences, and mathematics while I was there. They were just additional spaces I was interested in. I thought that they were relevant for R&D work. It's good to know how to work with data, and it's good to know how ingredients affect people. You don't just want to work with chemicals, so. And I kind of knew I was going to end up at P&G while I was a student. So it was kind of helpful to know, like, I can, pick and choose what I want to study while I'm in school to, cater for my career a little bit. And then I have a certificate in green chemistry and chemical stewardship from University of Washington that I got not long after graduating. So that's kind of tied into some of the work I've been doing at P&G, where a lot of it's around sustainability and naturals and everything else. So that was just kind of a way for me to focus a little more on that space. I am from Indiana, so I was born and raised in Columbus, Indiana. I now live in Cincinnati, so I haven't gone that far. Made a little triangle between Columbus and West Lafayette and Cincinnati, so not too far from my folks still. And yeah, so when I was in school, I did do 3 summer internships, so that kind of gave me a chance to try different things for a short period of time. So I did an internship in hair care, in skincare, and on APDO, which is the acronym for antiperspirants and deodorants. So yeah, and got pictures here of my pets. I call my dog my horse dog because she is that large, and a picture of my family here too. So what is Procter & Gamble? I wanted to include this slide because I think a lot of people recognize the brands that Procter & Gamble owns, but maybe not as many are familiar with the parent company. So P&G is an American multinational consumer goods corporation. It's headquartered in Cincinnati, Ohio, which, as I said, that's where I live and work now. The company has been around for a really long time. It was founded in 1837 by William Procter and James Gamble. We make a lot of different kinds of products. It's not just one category. So beauty is one of them, and that's where I work. But we also have grooming, healthcare, fabric and home care, baby, feminine, and family care. And in the past, P&G has owned brands in other segments as well. So like food and pet food, for example. So we've owned Pringles, Folgers, Iams, Aleve, Duracell, Crisco, Folgers, Jif, many more than that, actually. We've changed a lot over the years, and I guess that's to be expected when you're almost a 200-year-old company. So we have 99,000 global employees. I think about 10,000 of them are located in Cincinnati, where I am, but we also have employees that work in every continent, every country, pretty much in the world. So we like to have people working where the products are sold is kind of the idea, because you get more insight into the market there. So. And then I wanted to include this slide to talk a little bit more about responsible beauty. So I mentioned this on my intro slide, that this is kind of a space where a lot of my work has been falling recently. This is a new initiative by P&G within beauty that was founded by the CEO of P&G Beauty, Alex Keith. And it's a framework that basically helps us get to this goal of having better sustainability concepts in the work that we do. So it's the framework is designed around 5 different principles. Those are quality performance, safety, sustainability, transparency, and equality and inclusion. So this framework is the way that we get to our specifically defined goals. So we have these Ambition 2030 goals that are specific data points that we want to get to in terms of how we can change our global impact. So these goals are actually available online if you're ever curious what P&G is trying to get to. But yeah, that's been a fun and exciting thing to have bringing into P&G since I started my career, because for me, I have a lot of personal passion, I guess, for this kind of space. So it's really cool that we're focusing on it kind of as I'm getting a start here. Yeah, and then I've included this example here on the right. So this is actually one of the bigger examples of this responsible beauty program. Secret and Old Spice have 2 different variants of deodorant now that are offered in plastic-free packaging. So that it's like a cardboard tube basically that pushes up from the bottom. And I didn't design the packaging for this because I'm a formulator, but the formula that is inside of those packages is mine. So that's been really cool to kind of see this take off. Yeah.
That is cool.
Thanks. So now we can get a little bit more into deodorant. As I said, that's kind of been, where I started. I've had 3 years of deodorant work so far. But it is important maybe to understand the different kinds of sweat. You might notice that your armpits stink in a way that, when your leg or your arm sweats, it doesn't really smell like that. So the reasoning for that is that you have different kinds of sweat glands. So apocrine glands tend to connect into hair follicles. You can kind of see that here in this image. So anywhere that you have coarse hair is somewhere that you could have apocrine glands, if that makes sense. So that includes like underarm, pubic area, ear canal, yeah. And then eccrine glands are all over your body, and they're not just in specific spots. So these are the kind of sweat where you're exercising or something and you're just got, a sheen of sweat on your arm or something like that. Those would be eccrine glands. They do have different functions. So the apocrine glands, they're more hormonal and brought through puberty. So I think a lot of the history there is probably related to like reproduction and attracting mates and that kind of thing. But we still have those hormones and glands today in more modern times. And then the eccrine glands are less for communicating and more for just body regulation. So when you're hot, you need to be able to cool down. So that's kind of the thought there. And then the content of these sweats is different. So in apocrine sweat, you do have additional proteins and other compounds that are available for bacteria to eat and metabolize. And those ingredients that they produce after metabolizing the contents of your sweat are what smell. So, and when you have eccrine glands, the composition is just water and salt, and those aren't really consumable in the same way. So you don't get like stinky arms, like on the surface of your arm. But yep, so the apocrine glands are thought of as more being related to odor, since it's like a communication basis. That's how that area of anatomy kind of came to be. And then eccrine glands are more attributed for general wetness. But you do have both of these glands in your armpits, so that is important to know. Then to create body odor, I kind of got to this a little bit on the previous slide, but we have a ton of bacteria that live on our skin, and they are normal. It's your microbiome, you need them there. There's a lot of different estimates, but some put the estimate as 10 to the 14th power, which is quite a few. I think if you quantify that, there are some estimates that say that you have up to 5 pounds of microorganisms on your body on average. So 5 pounds of your weight is not you, it's bacteria.
Oh,
so,
wow.
Yeah, that kind of conceptualizes it. So, and then, so bacteria are a living organism. So just like people, they need food and water. So the water is mostly going to come from the eccrine sweat glands that provide most of the wetness. And then the food part is going to come from apocrine glands more so. So in addition to proteins, it's amino acids, oils, different kinds of like cholesterols and everything else. So then when, the bacteria get hungry, they need to eat food. And the same way that when we eat food, it turns into something else, that's what happens with bacteria. So those compounds are going to be on a future slide that I'll show you kind of how they attribute to different smells. But you can kind of start to see, why it is that some people might have more issues with body odor than others. So with stinkier people, you might have active eccrine glands, but you definitely have much more active apocrine glands because those are what are providing the odor. And then on less stinky people, you'd have probably less active glands of both is typically the case, because you would have less active apocrine, but you'd also have less active eccrine because there should be less water available to the bacteria too. So on stinky people, they have less diverse bacteria, which basically just means that for any one microorganism to start outnumbering all the other microorganisms is a lot easier. Like if you have less enemies, it's easier to win, is kind of the thought there. And then on less stinky people, you tend to have more diverse bacteria. So there's more competition between each individual microorganism. So it's harder for one to prevail over the rest and to produce like a lot of stink. And yes, for stinky people, you do need more humid underarms, and less stinky people would be less humid underarms. And that I think ends up just tying back to how active your eccrine glands are. So most people perceive, people with these stinky people tendencies to smell bad, and most people perceive people with these less stinky tendencies to not smell bad. So that is kind of how the difference comes to fruition. And then these are kind of some of the different metabolites that bacteria produce. So when bacteria eat the proteins and other compounds that are coming from your apocrine glands, these are some of the end products here. So in the underarm area, you tend to have a lot more of this particular peptide from sweat. So when that meets bacteria, it turns into this, and it smells like a, not a good smelling gym locker room. And then lactic acid tends to be a more common composition part of sweat on your feet. So more often, if your feet smell, it's going to smell more like a sour smell. And that's because bacteria are turning that lactic acid into this isovaleric acid ingredient that smells like a sour scent. So just like everything's made of chemicals, right? That includes your body odor. So just wanted to include that here. One important thing to maybe know is that deodorants and antiperspirants aren't the same thing. So when you have body odor, there are 3 different ways you can kind of fight that. So one way would be to get rid of the bacteria. So you can do that with antimicrobial ingredients. Another way would be to get rid of the sweat that they are consuming or drinking. And you could do that with an antiperspirant. So something that would keep the sweat from coming out. And then kind of as a more last ditch effort would be covering existing scents. So sometimes you'll still produce body odor, but there'll be perfume in your deodorant that helps cover that up. So these are kind of the 3 different approaches. So with deodorants, you get to fight odor in 2 of those ways. You use the antimicrobial ingredients and the perfume to cover any odor that pops through anyway. And since this product doesn't interfere with the functioning of any part of your body, it's deemed a cosmetic product, which means it's not regulated by the FDA for like claims of drug action. But then antiperspirants, they get to include all 3 of these mechanisms because they do also, in addition to the antimicrobials and perfumes, contain antiperspirant ingredients. And these ingredients actually form physical plugs in your pores to keep sweat from coming out. And since it's a physical plug inside your pore, that is interfering with a process of your body, and therefore the FDA deems it an over-the-counter drug product. So there are more regulations here in terms of making sure that the product works as well as it claims. So you have to test to see like how much aluminum antiperspirant ingredient is in this product and how active is it. So that's kind of some of the additional requirements that you get into when you go from being a cosmetic product to being an over-the-counter drug product. And so this is maybe just a little bit more explaining how antiperspirants work. So it kind of works on a pH gradient. So your skin is going to have a lower pH, I suppose, but it's higher than the pH of aluminum. The aluminum is very low pH. It's pretty acidic. So when it meets your pores, it'll kind of follow the pH gradient to try to neutralize itself and get closer to a neutral pH. And it will travel into the pore. And then at a certain point, its pH goes above a certain point where it's like a passing point, and it'll kind of solidify into a plug. So that's what this superficial plug is. So it does literally keep sweat from coming out. So yeah, so most aluminum actives are not just aluminum, they're aluminum polymers. So kind of have something here about that. They are hygroscopic and acidic, so they like to grab onto water, and they like to find more higher pHs. That explains why they go into your pores. And then too, they solidify when they crash out. So yeah, and then we have seen there's a difference in different aluminum polymers, where if you have smaller polymers, they're less bulky, I guess, and they can literally go deeper into the pore. And that does translate into an antiperspirant that works better than one where the pore isn't as deep. So there are differences there. So there are a bunch of different kinds of antiperspirants and deodorants, and I'm sure most of you would know this already from just going to the store. So these are just some of the different pictures you might know about, the difference between the blue sticks and the white sticks, or the kind where, gel comes out. This just kind of explains maybe the chemistry differences as well. So we call all stick products like this, where they touch you, contact forms. And then we also have a separate class of aerosol deodorants that are not as popular in the USA, but a lot of other countries, those are more popular, like in Latin America. So we sell a lot of aerosolized deodorant and antiperspirant down there, for example. But contact forms are kind of the king in the USA. So when you look at these sticks, they have a couple of main chemistry differences. One is that a whole half of them are free of water, and the other half of them are based around water. So the aqueous forms here, you have different options. So you can either have an emulsion, which is where you have like a water phase mixed with like a silicone kind of phase, and that thickens up and can form gels, for example. So you can get like clear gel, which is the one where the top surface is plastic, but when you crank it up, the clear comes through holes in that plastic. And then another kind would be a roll-on, which is probably becoming less popular these days, but it works as like a roller ball where you put the roller ball on your skin and your armpit, and that works as a deodorant as well. And then another option would be these deodorant sticks, which are single phase. So those are not emulsions where you have a water phase and like an oil phase. Basically, it's just a single phase there. And then the other half are going to be anhydrous, or we call them white sticks, but I mean, two of them are white. This one's kind of more off-white, honestly. That's why the quotes are there, I guess. But so you have two of these that contain aluminum. So that's the invisible solid and soft solid. So one of them is like a white stick, and then this one is kind of like the clear gel where you have the plastic cover with holes in it, but the product that comes out is white instead of clear. So this one ends up being an antiperspirant because it contains aluminum active, same as this one. But the natural deodorants are not going to contain that aluminum. The main difference here between the invisible solid and soft solid is just the amount of wax. So that's kind of like how you solidify formulas. If you have more wax, it'll be more solid. If you have less wax, it'll be more like a cream. So if you get the wax levels low enough, you can have something that can squeeze up through holes still, is kind of the idea here. And then these aluminum-free natural deodorant sticks are kind of where I've been working a lot on. This has become a much more popular area. So it's good to, innovate in new spaces as they become more popular. It's good for the health of the company. And this is a little bit of history about how all these forms came to be. Like, you might think, like, why are all of these necessary? Can't we just all use the same thing? But there have been different drivers over time. So the first ever deodorant to be created was this mum cream on the far left. So that was a zinc oxide paste. And you had to apply it with your fingertips. You would scoop it out of a jar and smear it on your armpit directly. So you had to, wash your hands afterwards, which isn't as fun, but it was pretty innovative at the time. Before this period, there weren't products available to help people with underarm sweat of any kind, antiperspirant, deodorant, or anything. So people just smelled the way they smelled pretty much, unless they were trying to, put fragrance on or something like that. It would have been different. And then as time kind of passed, the first antiperspirant was formulated. That's this EverDry product. It was made very acidically, and actually it was so acidic that it would sometimes burn holes in people's shirts, like through the armpit. Yeah. So aluminum, as I said earlier, is acidic, but if you include too much of it, or if you have other ingredients that interfere with it, it can cause that acidity to really shine through. So yeah, so that also, of course, if it was able to burn through shirts, it was irritating people as well, like on their skin. So that was a good start, but we could probably be better than that. So we have continued over time to, improve from there. And typically, I don't think most people find that antiperspirant burns through their shirts. And then as we get into the 1900s, these roll-ons start to become popular. So these were roll-on deodorants. So I think I mentioned earlier, roll-ons I don't think are as popular now, but they certainly had their moment in time. This was kind of the first product where you could just directly touch it and it would, impart its ingredients on. And then in the 1960s, you get the first aerosolized APDO product. It's this Gillette Right Guard product. It was very different for its time. It was, the first aerosolized product, as that, it's very different, of course, than these things where you're either smearing it on or touching it to you. But Unfortunately, the earlier aerosols were not great in terms of regulations. So, not very long after this product launched in the 1960s, in the 1970s, there were new regulations that came to be, and those started limiting what could be sold as an aerosolized product in order for it to be safe for people and safe for the planet. So then as the 1970s aerosol regulation came about, there hadn't really been a lot of other innovations in a couple decades besides the roll-ons. So there was a big opportunity area between the 1980s and the 2000s to bring about some new forms. So sustainability actually ended up being a key reason that these stick products came to be, because those regulations were kind of forcing it to, there needed to be an alternative, I guess. So that's how you get to these invisible solid and clear gel formulas. And then as we've kind of come into the 2010s and onward, so, since I've joined the company, there's been a new push where people are becoming more, they're using more scrutiny on the products they use. They're more aware of what is in the products, like what the ingredients do. They don't just necessarily buy what's in the store. They might look it up online first. And then you also have a new class of people that are considering how their purchases affect sustainability, to the point that they'll buy things that are a lot more expensive if it's noticeably more sustainable than what's already available. So that kind of new awareness and new priority has brought about some of these natural deodorants that are aluminum free. So this is just a slide that includes some of the different classes of ingredients in natural deodorant formulation. So this is the space where I've been working. So really the basis is that you have active ingredients. So these are not drug active ingredients because they're not aluminum, but they do still, work against bacteria. So in order to work against these bacteria that prefer a neutral pH, you can either raise the pH down like antiperspirants do, or you can go up. So there's a lot of high pH salts that are pretty common and recognizable to people. For example, baking soda, magnesium hydroxide, which is milk of magnesia, and then magnesium oxide as well. So these ingredients, when you sweat, if these ingredients are in your deodorant, your sweat will dissolve these high pH salts in your sweat, raise the pH, and then bacteria don't want to drink that water. It's too intense for them, is kind of the thought. So you end up taking away their food sources as well, because the shift in pH also ends up reacting with those sweat metabolites. So they're not the same chemical anymore. And then bacteria can't do the same things with them that they could have done otherwise. So that's the main way that we fight odor causing bacteria with this form. Another opportunity is to look at more potent antimicrobials. So one of them is this proctenolamine. So this ingredient is included at a much lower level because the way it works is not by pH. The way it works is by directly interfering with bacteria. So it'll interfere with their metabolic processes, and then that keeps them from being able to function, and then they can't survive. So those are the basic actives, but you need something to deliver these actives in. So that's kind of where these other ingredients come through. So you need basically a structurant, or a wax is kind of what we call it. Well, it is wax. We call it a structurant is what I meant. But these are what make stick products solid. So if you have a deodorant where it's just a stick and you press it against your skin, it's able to do that without smearing because it has wax in it. And then in addition to wax, you kind of need something to dilute that wax with. Like if you just rub wax on your skin, that's not going to feel very good. It'll be very draggy. So you need enough liquid in there to kind of dilute out that wax. And then that's where these oils and butters are coming in for natural deodorants. So people don't want to see like petroleum derived liquids. Like there's a lot of petroleum derived liquids available. There's also a lot of silicone based ingredients that are liquids, but people like to see coconut oil or shea butter a lot more than they like to see stuff like that. So that's kind of where we've focused. And then in addition to having like this mix of, diluted wax, I suppose, there's also a need to kind of adjust aesthetics. So it's basically changing how the product feels when you apply it or while you're wearing it. So it can, like, if you, I mean, it's an oil and a butter, right? So if you have oil in your armpit, it might feel like you have something greasy in there, and that's not going to be very enjoyable, even if it does work as a product. So by including starch in the formula, these, these particles of starch are kind of like big squishy particles that they basically are really good at hiding greasy feel. So if you have a layer of oil on your skin and you have a ball bearing that kind of, it stands between your finger and the skin, you'll feel the particle before you feel the oil, if that makes sense. Okay. So it changes your perception of feel is kind of the thought there. The other thought here is that since these are a big particle, they can also adsorb to sweat. So it's not keeping you from sweating, but what it's doing is it interacts with the sweat that comes out of your pores and just kind of can hide them the same way that it might hide the oil in your formula. So we kind of think of this as being a good way to make the product feel dry, even if people are sweating, which they will if it's a deodorant. There's nothing to keep you from sweating when you're wearing deodorant. And then the perfume is kind of the last touch. So that's the kind of the final the final line of defense, I suppose. So if you still get some body odor, the perfume in there would cover it up. So we have two different ways to put perfume into our products. So one of them is liquid perfume, which is just going to be like an instant release kind of way to deliver scent. And then we have another fragrance technology called beta cyclodextrin, which is a powder that is basically the molecule is shaped like a donut. And inside the donut hole, you can put a fragrance molecule. And the donut won't release the fragrance molecule unless it encounters sweat, like water. So it's kind of like you can have an extended release of fragrance throughout the day, is the thought there. So you can kind of have something that covers you at first, like if you're at the gym and you need to put deodorant on again, perfume will cover you then. But if you put on deodorant at the beginning of the day, you go to a meeting, you have something stressful happen, then BCDs can kind of come in and save the day there. So these are all the ingredients, but you have to put them together in a way that produces a deodorant stick, right? So you can't just, put everything in a container, mix it together and call it a day. It's a little more complicated than that. So the way that we basically will make most deodorant products is that we start by combining the waxes, oils, and butters in a container. So I work in a small scale lab. So a lot of the time I make batches in glass beakers, but I work with people who more focus on scale up. So they will work in bigger metal tanks because they want to know how does the batching change as we increase the size, because eventually most of our formulas would get made at an industrial kind of production scale where you have tanks that could take up a small house, for example. So it becomes it becomes important to be able to have that parallel between my tiny little beaker batch and a tank the size of my house. So so with these ingredients in the container, you melt them up to just above the melting temperature of the wax with stirring. So at this point, you should have all liquids in the container, thanks to the heating. And then as you begin to cool, you start adding in the other ingredients. So you go from just above the melt temperature of the wax where it's a liquid, and then you want to go down approaching the crystallization point of the wax, but not passing it, because if you do that, your batch will solidify in the tank and in the lines, and then you have to clean up solid deodorant versus a liquid. So that's never fun, and I've been in that situation before. So you have to stay in a tightly defined range is basically what this ends up meaning. So you then begin adding all the powder ingredients. So I like to start with the salts first. The reason for that is that salts can't burn. So they're ionic compounds, right? So when you add them in first at the higher temperatures, they can withstand that. And then after you've added in all the salts, that's when you'd start adding some of the other ingredients, like starch might be next, because starch can burn. I don't know if you've ever made rice in a pot, you can get like a sticky residue that forms on the bottom of the pot. That's just the starch burning. So you want to be careful with starches. If you add them too hot, you can get crystallized rocks kind of in your formula, and then that's not fun because no one wants crystallized rocks to rub against their skin when they apply deodorant. And then as you go, the last thing that ends up getting added is the perfumes. So the BCDs go in first because that's still a powder ingredient, and then perfume next. The reason we do these last is that perfume ingredients are very susceptible to high pH, so they tend to just be more reactive. So if we put them in early, then they'll be exposed to the high pH salt ingredients with high heat for a longer period of time. And that can make the perfume ingredients react and turn into different compounds that don't smell the same as the original compounds smelled like. Because again, everything's chemicals, right? So, and that includes perfume. So a molecule that smells one way will smell different if you change the structure of the molecule. So then at this point, everything's in the container. You don't have any more ingredients to add. We'll do a mill step, which is basically a piece of equipment that will chop up the formula while it's still wet and molten. And that just basically will break up any powder agglomerates. Sometimes you'll get globs of different powders that'll sit in the tank and not really get mixed in easily. And then as you cool, you get close to that crystallization temperature and you pour the formula directly into the deodorant canisters. And then as it solidifies, it forms the shape of your stick. So it is that, those are the basic steps basically. So if I was making it in a beaker, the whole thing would be happening in a little glass beaker, and I would pour my beaker into canisters right here by hand. In a scaled up production kind of facility, they would have a piece of equipment that has fillers on it so you can automate it better. Like you don't have to do, of course, not every deodorant stick you buy is going to be hand poured by a person. That wouldn't scale very well. So we have to be able to make a lot of product cost efficiently. So the more automation we can get as we scale, the better is the thought there.
That makes sense.
Right? And then, so kind of a last piece I wanted to include is a little bit more information about what patents can do for us in this space. So I mentioned earlier that I have 2 patents now. These patents have actually been pretty important to us because some of the work I did earlier on in my career was to formulate native deodorant. So this product, we ended up patenting a formulation space. So it basically defines different ranges of ingredients, different physical attributes of the deodorant stick. Like we say, like if it's this hard or soft, then it falls in the patent. We say like if it has more than 25% of this ingredient, then it falls in the patent. Things like that help us define a very broad space. And then the broader the space is, the further we can keep competitors away from us. Okay. So for example, this Equate product here on the right was marketed as a generic native deodorant. It has it right there on the front label. They're not even hiding it. Even use the same scent name as we use on one of our most popular products. But what you find when you flip over the stick and compare the ingredients, they're all in a really different order. And the order does matter. The way that ingredient statements work is the ingredient that's first is in there at the highest level. And then as you go down, it decreases. So in this generic product, they have a bunch of powders and solids included as the first 4 or 5 ingredients, I think. And then as you get down to this caprylic glyceride, which for us is the first ingredient, it's in there at an apparently much lower level. And you can tell that when I tried this formula, it's really draggy and hard and it skips across your skin, doesn't feel good. So I actually think this isn't a product that's for sale anymore. And it's probably because it wasn't doing very well, even though it was being sold at a much cheaper price. Native is for sale at $11.99 per stick. And this Equate product was being sold, I think, at like $5.75 or something like that. So even with that price win, it wasn't enough for people to say, yeah, that's good enough. It's comparable. So that's been important for us. Otherwise, there's nothing that would keep competitors from just copying our ingredient statement and including all of the ingredients in there at the same levels as us. They wouldn't know like how we made it, like they wouldn't know what equipment we used to make it, but they could tell at least like the differences in levels between all the different compounds. So that is certainly an important thing to pursue patents.
I've always wondered the difference. I'm glad you explained that.
Yeah, no, that's great. Awesome. And that's all the slides I had. So free to answer anything else that you guys might have had come up while I was talking through all that.
I have a couple of questions, but I guess the first one, what is it about aluminum? I know you've mentioned a couple of times, like some deodorants include aluminum, and that seems to be like what's helping that antiperspirant work, but then your work is in aluminum free. And so maybe could we start with talking about aluminum deodorants versus aluminum free deodorants?
Sure. Yeah, so if you remember from when I was talking through the history of APDOs, there have been different regulations over time that say like it's not okay to sell things that meet this criteria. So with aluminum, that's been kind of one that's been swimming around in the press for a while, I guess, is that there have been some studies that have shown that aluminum can be linked to, certain kinds of cancer. I think breast cancer is one popular study that's been shown. I think the reason that there haven't been regulations around that study yet is that there are parts of that study that were a little fuzzy or not as well tracked. So I think the FDA wants to make sure that before they regulate something, they have convincing evidence that this needs to be regulated. So for now, it's kind of like there's multiple studies out there that might suggest that aluminum is, winding up in places that it shouldn't or causing things on your body that it shouldn't. But the issue so far has been, the quality of data available hasn't been convincing enough. But consumers do their own research. They can Google things just as easily as I can, So they have been able to look at some of these studies and make some of their own conclusions. And that's understandable. A lot of people have started doing that in general. Like they're saying, I don't, eat foods that contain this, or I don't use products that are made in this way. So I think what you have is maybe people that are choosing to interpret that data to be safe. And that's, I've kind of been in that camp myself. Like I used to wear antiperspirant when I was younger. And then when I started working here and started working aluminum-free deodorant, I started wearing my products and realized, this is enough for me. I don't think I sweat enough to really need antiperspirant. So if it's uncertain, then might as well just wear the product that definitely doesn't have any issues to it, is kind of my thinking. But so some of that FDA work and the extent of those studies is kind of not in the role that I have. That ends up being, a lot more intense research from academic spaces. But it certainly would impact us if such a study ever came to be, because while we do sell a lot of deodorants, and that's what I work on, we also sell a lot of antiperspirants with aluminum. And there are a lot of people that would need a product to replace aluminum that works as well as aluminum. And currently that's not really technically possible. So that's kind of been a struggle too, I think, is we want to replace aluminum, but we only want to do it if it is going to work as well as what we've had before. So that's kind of been the struggle, I think, on some of our bigger brands. On the brands I work on, I think the priority is more to produce products that consumers want to buy, because, if they don't want to buy aluminum, they're not going to buy it. So we need to offer them an alternative. So that's kind of where, my space of work has kind of been defined differently from some of the other products that we've made.
I know I'm glad your division's there, because years ago I went aluminum free, and it took a while to find it.
Yep. Yeah.
That wasn't easy.
Right. Yeah. And you're right. There were not as many choices, maybe just as recent as 5 years ago. But since then, there have been a lot of new small brands that are popping up. And I think that's because even as people see, like, well, if a lot of the big brands are just doing aluminum products, then I can offer something that I know people want to buy, and I can make my own money and have a successful brand around that. So I think as time passes, maybe the big brands will continue to catch up and start offering, more aluminum free options. But it's, the bigger you are, the more momentum you need to change. So, yep.
That makes sense.
I just had one other thing I just wanted to ask you, because you have had some success with, you said a couple of patents.
Yes.
And you had mentioned that the native deodorant that's being sold, and it's quite a bit more expensive, but like you said, I mean, just the way it was formulated and things, if that's the market and that's what people are looking for, that they're okay with, buying something like that. But I didn't know if you could speak a little bit about the importance of funding that kind of research towards patents, how important that is to get these patents, so that or why it's necessary, so that like it's not, I don't know if I'm asking this right, just so not everybody could copy it. Like what can you say a little bit about why that's important?
Sure, yeah. So I guess the main issue is that there are so many competitors out there that if we produce one thing and people say, well, there's no patent on that, they can make a lot of money producing the same thing without nearly as much work as we put into it. So when you get a patent, I think maybe the thought process behind why that's important for you is that you've put in a lot of your own work into figuring out something brand new that no one's ever done before. So to put in all that work, there are certain spaces where, for example, with deodorant, where there wouldn't necessarily be protection guaranteed to you. It's not a product that isn't going to be easily copied, I suppose. So I find that my managers and managers of those managers, they all prioritize patent work because they realize that first of all, patents last 20 years plus. So for example, I just had a patent issued last month, and that will protect our formula until 2040, which is a really long time. So yeah. We basically will get 20 years to profit off of the work we did. And then at that point, people could, when the patent is expired, at that point, people could start making products that fall into the old definition of that patent. But we would have had so much time to grow and learn during that time that, we could continue to grow in that space. So I guess it's important for innovators. It's not as fun to find patents if you're trying to copy someone else, but it is nice if you're the inventor to know that you're kind of protected in that sense. But yep. So and that is how it works. If a patent defines a space and you get it granted, then nothing else from anyone else is allowed to exist if it falls into your patent, because technically that is it's called intellectual property for a reason, right? Like it is your property, like the work you did is your own. So it's nice to have that kind of protection. Otherwise, I think it would be hard to want to innovate at all, because it would feel like you do all the work and everybody else gets all the benefit. So it is nice from my field, I guess.
Thank you. That's an awesome explanation. I think that would make sense to people that maybe didn't understand what patents were. So
yeah, thank you.